At Arizona State University, we've made online education better, smarter, and more personalized so you can go further in your aspiring field.
I decided to pursue medicine once I realized that ASU did have the online program for biological sciences. You're still required to learn the same curriculum. You're still being tested on the same content that anyone would be tested on in person. The comprehensiveness of the program prepared me so well for medical school.
Explore over 350 plus programs at asuonline.asu.edu.
I earned my degree online at Arizona State University. I chose to get my degree at ASU because I knew that I'd get a quality education, they were recognized for excellence, and that I would be prepared for the workforce upon graduating. To be associated with ASU, both as a student and alum, it makes me extremely proud, and having experienced the program, I know now that I'm set up for success. Learn more at asuonline.asu.edu.
Welcome to the Deep Dive. Today, we're really getting into it, the whole world of artificial intelligence. We're pulling from this massive, 50,000-word piece on AI. So your mission, if you stick with us, is basically to get a really solid but, understandable grip on AI. What it is, what it does, why it's such a big deal.
Exactly. Think of it as the essential guide. We've waded through the dense stuff so you don't have to. We're hitting the main ideas, the really key developments, and how it all connects.
Yeah, and things are moving so fast, aren't they? It's kind of mind-blowing. AI isn't just theory anymore. It's like recommending songs, helping doctors.
Totally. It's woven into the fabric now.
Okay, so big topic. Where do we even start trying to unpack all this?
Good question. I think the best place is just defining it. What is artificial intelligence, really? At its heart, it's about building smart systems, agents, we sometimes call them, systems that can reason, that can learn from information, and crucially, act on their own.
Right. So the goal is to kind of replicate human thinking, learning, solving problems, that sort of thing.
That's often the inspiration, yeah. Mimicking cognitive abilities. But it's important to remember there's a spectrum.
Ah, okay. Because the AI in my phone feels very different from, HAL 9000.
Exactly. You've got narrow AI or weak AI. That's designed for one specific job. Playing chess, recognizing faces and photos, filtering spam, very focused.
Right.
Then there's the big one, general AI or strong AI. That's a hypothetical human-level intelligence across pretty much any task.
Still sci-fi for now, then?
Pretty much.
Yeah.
And even within AI, there's this range of how autonomous they are. Some just follow rules we give them. Others, especially with deep learning, can genuinely learn and adapt more freely.
So it's not just about copying humans. Sometimes AI can do things we can't, or do them way faster.
That's a really key point. It's not just mimicry. It's about potentially expanding our capabilities, solving really complex problems, maybe even ones we haven't thought of.
Okay, a tool multiplier, not just a copycat. Got it. So how does this intelligence actually happen? What are the building blocks?
Yeah, let's get into the pillars. You basically have three core concepts: machine learning, deep learning, and neural networks.
Okay.
Machine learning, ML for short, is all about algorithms learning from data, instead of programming every single rule.
You just feed it data and it figures things out.
Pretty much. It learns patterns, makes predictions. That's the core idea.
And there are different ways it learns.
Yep. There's supervised learning, where the data has labels, like showing it pictures of cats and dogs and telling it which is which.
Okay, learning with answers provided.
Right. Then unsupervised learning, no labels. The AI has to find patterns and structures all by itself in the raw data.
Like finding hidden groups in customer data or something.
Exactly. And then there's reinforcement learning. That's learning by trial and error, getting rewards for good actions, penalties for bad ones. Think training a robot dog.
Ah, okay. Learning through feedback. Makes sense. And deep learning, that sounds deeper.
It is, kind of. It's a subset of machine learning, but it's behind a lot of the really impressive recent stuff. It uses these artificial neural networks with many, many layers. That's the deep part.
Layers of processing.
Yeah, think of it like information passing through multiple filters, each extracting more complex features. So you have things like CNNs.
Convolutional neural networks.
Right, great for images and video. And RNNs, recurrent neural networks.
Yeah.
And LSTMs. Those are better for sequential stuff, like language or maybe stock market data.
So that's how AI can see a cat in a photo or understand what I'm saying through these deep networks.
That's a huge part of it, yes. And all these deep learning models are built on the idea of neural networks themselves.
Which are inspired by the brain, right?
Loosely inspired, yeah. Imagine interconnected nodes like neurons. They process information. You have an input layer, hidden layers in the middle doing the work, and an output layer giving the result.
And the connections matter.
Critically, the connections have weights and biases. Think of them like volume knobs and baseline settings that get tuned as the network learns from data.
Adjusting the connections based on what works.
Exactly. Which brings us to the fuel.
Data. You always hear about AI needing tons of data.
Absolutely fundamental.
Yeah.
The AI is only as good as the data it learns from. Quantity matters, sure, but so do quality and diversity.
Garbage in, garbage out, basically.
Precisely. And it's not just getting the data, it's the whole life cycle.
What does that involve?
Well, first you acquire it, collect it. Then you have to clean it up pre-processing. Fixing errors, handling missing values, super important.
Right. Can't learn well from messy data.
Then you do feature engineering, figuring out what parts of the data are actually useful and maybe transforming them. Then you train the model, feeding it the prepared data, letting it adjust those weights and biases.
Okay.
After that, you evaluate it. How accurate is it? Is it reliable? And often, the learning continues. The model keeps adapting as it sees new data.
Wow, that sounds like a lot more work than just hitting upload.
Oh, it's meticulous. Definitely.
Yeah.
So AI learns from data, but it also needs to think, right? Reason and solve problems.
Yeah, that's the intelligence pit, isn't it? Going beyond just pattern matching.
Exactly. Early AI used rule-based systems. Basically, complex if-then statements programmed by humans.
Like a giant decision tree.
Kind of, yeah. Then there's knowledge representation. How do you structure information so the AI can actually use it? Like building maps of concepts and relationships, semantic networks, ontologies, ways to organize knowledge.
Giving it a framework for understanding.
Right. And for finding solutions, you have search algorithms, ways for the AI to explore possibilities efficiently, breadth first, depth first, A-star, different strategies, plus logic and inference, applying formal reasoning, and importantly, planning and making decisions even when things are uncertain, which is most of the real world.
It's amazing how many different approaches there are to tackling thinking. Okay, the last piece you mentioned was perception and interaction. How does AI connect to the world?
Crucial part. It needs to sense and act. So computer vision lets AI see, interpret images, video, object recognition, facial recognition, understanding a scene.
Like in self-driving cars.
Definitely. Then natural language processing, NLP. That's understanding and generating human language. Text analysis, translation, chatbots.
My voice assistant understanding me.
Exactly. That also involves speech recognition, voice to text, and speech synthesis text back to voice.
Okay.
Combine AI with physical bodies, you get robotics, AI controlling movement and actions, and making it all usable for us. That's human-computer interaction, HCI. Designing interfaces so we can actually work with these systems.
It really is a whole ecosystem of technologies working together. Okay, foundations covered. Let's talk applications. Where's all this stuff actually being used? It feels like everywhere now.
It really is spreading rapidly. Let's start with something many of us interact with, content creation.
AI writing articles, generating images, still feels a bit wild.
It's happening. Large language models are powering tools that write articles, marketing copy, even code or scripts. And visually, you have diffusion models, GANs. They can create incredibly realistic or artistic images just from text descriptions.
I've seen those. Pretty amazing. Sometimes uncanny.
Definitely. And it's moving into music generation, even basic video creation from text or images. Plus, as you mentioned, AI helping developers write code, suggesting fixes, boosting productivity.
Okay, so content creation is being transformed. What about customer service? We've all dealt with chatbots.
Yeah, that's a huge area. AI chatbots and virtual assistants provide that 24/7 support. Chatbots handle common questions, basic issues. Virtual assistants can do more schedule things, place orders. Key tech there is natural language. Understanding NLU, figuring out what the customer means, and sentiment analysis, reading the mood.
Trying to tell if I'm getting angry.
Basically, yes. And integrating with CRM systems means they can personalize the interaction more, pulling up your history. It's aiming for seamless support across channels.
Right. Okay, shifting to a really critical area, healthcare. The potential seems enormous.
It really is. Medical image analysis is a big one. AI helping radiologists spot signs of disease in X-rays, MRIs, CT scans, sometimes finding things human eyes might miss.
Wow.
It's speeding up drug discovery, identifying potential candidates much faster. Personalized medicine tailoring treatments based on your specific genetic makeup. Lifestyle data AI is key to analyzing all that complexity.
That's the future.
It seems to be heading that way. Plus, robotic surgery assisted by AI for more precision, using AI to predict disease outbreaks or identify at-risk patients, and powering telemedicine platforms.
Incredible impact potential. Okay, what about getting around? Transportation. Self-driving cars are the obvious one.
Absolutely. Autonomous vehicles rely heavily on AI. Computer vision interprets sensor data cameras, LiDAR, radar to see the road.
Right.
AI algorithms plan the route, make driving decisions in real time. Sensor fusion combines all that incoming data. Machine learning helps them learn from driving patterns to get safer.
It's a whole different level of complexity.
It is. And you also have AI optimizing traffic flow, managing fleets of vehicles, coordinating through V2X communication. It's reshaping logistics, too.
Okay, industry next. Manufacturing. Seems like a natural fit for AI and automation.
Definitely. AI-powered robots are doing assembly, moving materials. Predictive maintenance is huge, analyzing sensor data from machines to predict failures before they happen. Saves downtime, saves money. There's quality control, too. AI spotting defects from images or sensor readings way faster and maybe more consistently than humans. Optimizing supply chains, forecasting demand, even creating digital twins.
Digital twins.
Yeah, virtual replicas of a factory or a machine. You can run simulations, test changes, optimize processes using AI on the twin before doing it in the real world.
Very cool. What about education? How is AI changing learning?
Big potential here for personalization. AI platforms that adapt learning materials to each student's pace and style. Intelligent tutoring systems offering one-on-one help.
Like a personal tutor for everyone.
That's the dream. Also, automating grading for certain types of assignments, helping with administrative tasks like scheduling, and maybe even identifying learning difficulties earlier through data analysis.
Could really change the classroom experience. Okay, finance always quick to adopt tech. What's AI doing there?
A lot. Fraud detection is massive AI spots. Unusual transaction patterns that might indicate fraud. Risk management, assessing credit risk, market risk. Algorithmic trading, where AI makes buy-sell decisions based on data, is huge.
Right, high-frequency trading and all that.
Exactly. Also, using AI in customer relationship management for personalized offers, and even helping banks with regulatory compliance, like spotting money laundering.
Sounds like it's becoming indispensable. Is it reaching into more traditional industries too, like agriculture?
Surprisingly, yes. Precision agriculture is the term. Using AI with drone or satellite imagery to monitor crop health. Optimizing irrigation and fertilizer use based on sensor data, saving water, resources.
Smart farming.
Yeah. Autonomous tractors and harvesters are being developed. AI helping with weather forecasting specific to farms, even monitoring livestock health and behavior using sensors or cameras.
Amazing. Really touches everything. Okay, what about entertainment, beyond just recommendations?
We touched on content generation, AI music, AI art. Personalized recommendations are obviously huge, powered by ML. But also in game development, AI designing characters, generating game environments, interactive storytelling where the narrative changes based on your choices, influenced by AI.
Making games more dynamic.
Potentially, yeah. And then there's the more controversial stuff like deepfakes, synthetic media, AI creating realistic but fake video or audio. Big ethical questions there.
We'll definitely get to the ethics. Okay, one more application area.
Right.
Security and surveillance.
Right. AI analyzing video feeds to spot suspicious activity. Cybersecurity AI detecting network intrusions or malware by finding anomalies in traffic patterns. Facial recognition for identification, access control.
That one's definitely controversial too.
Very much so. And anomaly detection in industrial settings to spot malfunctions or security breaches. Even predictive policing, trying to forecast where crime might occur, another area with huge ethical debates.
Okay, that's an incredible range. It's clear AI is powerful and pervasive, but that power brings up, well, the tough questions. The ethical side.
Absolutely crucial. And maybe the most important part of the conversation long term. Bias is a huge one.
AI being biased, how does that happen? Isn't it just code?
But it learns from data. If the data reflects historical biases, sexism, racism, the AI learns those biases. Or if the developers make flawed assumptions. Or if the data just isn't diverse enough.
And this shows up where?
All over. Predictive policing algorithms showing bias against certain neighborhoods. Resume screening tools favoring male candidates because they were trained on past hiring data. Loan applications, even healthcare diagnostics. If the training data isn't representative, the outcomes can be unfair.
Wow, so how do you even fix that?
It's really hard. Defining fairness mathematically is tricky. But things like ensuring data diversity, auditing algorithms for bias, demanding more transparency and explainability, those are steps.
Explainability, knowing why the AI made a decision.
Exactly. Which leads into the black box problem, especially with deep learning. It can be really hard to understand the internal logic.
Okay, bias is huge.
Right.
What else? Privacy seems like a big concern.
Massive. AI thrives on data, often personal data. Facial recognition is a prime example. Its use in public surveillance. Potential for misuse.
Yeah, the idea of being constantly watched and identified.
It's concerning. NLP can also be used to monitor communications, extract personal info. And AI is great at aggregating data from different sources to build incredibly detailed profiles of individuals.
So it's this trade-off between security or convenience and privacy.
Often, yeah. Finding that balance is key. And that's where regulations like GDPR in Europe come in, trying to set rules for data privacy. But technology often moves faster than laws.
True. Okay, what about accountability? If a self-driving car crashes, who's responsible?
The million-dollar question, almost literally. The black box problem makes it hard to trace why an error occurred. Is it the programmer, the data provider, the owner, the AI itself?
Tricky.
Very, especially with autonomous systems. We need clear legal and ethical framework to assign liability. Auditing and explainability can help trace errors, but it's still a developing area. Even in AI-assisted decisions, like a doctor using an AI diagnostic tool, figuring out the balance of human and AI responsibility is complex.
Definitely thorny issues. Another big one everyone talks about is jobs. Will AI automate us all out of work?
It's a valid concern. AI is definitely good at automating routine tasks, both manual ones in factories and cognitive ones like data entry or analysis.
Which sectors are most affected?
Manufacturing, transportation, customer service, data entry. Those are often cited. But even some creative fields might see changes with AI content generation.
But does it also create new jobs?
It does. Jobs in AI development, data science, AI ethics, maintenance of AI systems. But the transition is the challenge. Will the new jobs require different skills? Will people be displaced faster than they can retrain?
So we need, like, massive retraining efforts.
Probably. Reskilling and upskilling initiatives will be crucial. And it raises bigger questions about social safety nets. Maybe even ideas like universal basic income if automation becomes widespread.
A fundamental shift, potentially. Okay, the last ethical point, and maybe the scariest for some, existential risk. Superintelligence.
Yeah, the long-term, more speculative risks associated with artificial general intelligence, or AGI, and potentially superintelligence AI, far surpassing human intellect.
This is the Skynet scenario.
Sort of the Hollywood version. The real concerns are more nuanced, like the alignment problem.
Yeah.
How do we ensure that the goals of a highly advanced AI remain aligned with human values and well-being? What if its goals, even if seemingly benign, lead to unforeseen negative consequences for us?
Because it might achieve its goal in a way we didn't intend.
Exactly. Or the control problem. How do we maintain meaningful control over something potentially much smarter than us? These are theoretical now, but AI safety research is actively working on these problems, thinking about the long-term trajectory.
Definitely things to keep an eye on. Okay, we've covered the tech, the uses, the ethics. Let's look globally. How are different countries handling this AI revolution? You mentioned the U.S. earlier.
Right. The U.S. has been a leader, largely driven by the private sector. Big tech companies, Google, Microsoft, Amazon, Meta, plus top universities like Stanford, MIT, and a really dynamic startup scene. Government funding exists, but it's often market forces leading the way.
Lots of innovation, market-driven. What about China? Sounds like a different model.
Very different, much more state-directed. China has explicit national strategies aiming for AI supremacy by 2030, backed by huge government investment.
And they have a data advantage.
Massive data advantage, yes. Large population, widespread digital payment systems, less stringent privacy norms in practice, gives them vast data sets for training AI, especially in areas like facial recognition and surveillance where they're very strong.
But that raises human rights concerns.
Absolutely. The use of AI for surveillance and social credit systems in China is a major point of international concern.
Okay, U.S. and China as two poles. What about Europe?
Europe is trying to carve out a third way, balancing innovation with strong regulation and what they call human-centric AI. The EU AI Act is the centerpiece, trying to govern AI based on risk level, banning some uses, heavily regulating others.
More focus on ethics and rules up front.
Definitely. A big emphasis on trustworthy AI, explainable AI, XAI, and data privacy under GDPR. Lots of public-private partnerships trying to foster AI development within those ethical boundaries, particularly in sectors like healthcare and manufacturing.
Interesting. So regulation forward, are there other key players we should mention?
For sure. Canada has a really strong AI research ecosystem, especially around deep learning pioneers, and a significant focus on ethics as well. The UK is pushing hard on AI safety research and setting up its own regulatory frameworks post-Brexit.
Okay.
Japan is leveraging its strengths in robotics, integrating AI there. South Korea is powerful in AI for electronics and manufacturing. And India has a huge talent pool, looking to apply AI in areas like agriculture and healthcare to solve specific national challenges.
So it's truly a global phenomenon, but with distinct national flavors and priorities. What are the big picture geopolitical implications?
Well, AI is seen as fundamental for future economic competitiveness. Nations are racing to attract talent, foster startups, and lead in key AI applications. It's also becoming central to national security and defense.
An AI arms race.
There are definitely concerns about that, particularly in autonomous weapons development. But it's also about economic dominance, technological leadership, and potentially influencing global standards and norms around AI use. It's a new dimension of geopolitical competition.
So AI isn't just changing our lives and industries, it's reshaping global power dynamics too. That's a lot.
It really is. We've gone from the basic building blocks to global strategy.
We really have. We covered the foundations, ML, DL, neural nets, data, then the applications, which are just everywhere: content, healthcare, transport, finance.
Right across the board.
Then the really crucial ethical crossroads: bias, privacy, jobs, accountability, even those bigger existential questions.
Yeah, the societal impact.
And finally, how different countries are approaching this whole thing. The US, China, Europe, others. Different strategies, different priorities.
A truly global picture.
For me, the sheer breadth of applications was eye-opening, and also just how central data quality and bias are to making this work responsibly.
Yeah, those ethical considerations can't be an afterthought. They have to be baked in from the start. It's clear AI is transformative, and we're really just scratching the surface.
Absolutely. So as we wrap up, maybe something for you, the listener, to think about. Given everything we've discussed, the power, the potential, the pitfalls, what kind of future do you want AI to help create? And what role should we all play in steering it that way?
That's the big question, isn't it? It's not just happening to us. We have choices to make.